Welcome everyone to the fifth video of the COA lecture series, and today's topic is addressing modes. But before that, we should know that why are we learning this topic? If you are a programmer, then you know that we need to write a piece of code or program to make the computer understand that what we want it to do. So to instruct the processor while programming, we need code, and that can be understood by addressing modes. So what is the definition of addressing mode? The manner in which an operand is given in an instruction. I know that instruction or operand, these are quite a few terms which are not familiar to you. I will discuss all of them in this upcoming 5 minutes. But before that, just read this definition once again. That the manner in which an operand is given in an instruction. Say for example, add 20h. This is an instruction. This 20h is the operand. So how this 20h is used in this instruction, this type of this manner is called addressing mode. Suppose this is an example of immediate addressing mode. Okay. Before jumping into the main topic, there are some basic requirements that is strictly needed to understand this video, because I'm gonna use quite a few terms so repeatedly. If you don't know them, if you don't know these terms clearly, then you can't understand this video tutorial. So for the upcoming 5 minutes, please listen to this very carefully and understand these basic requirements. First of all, you should know what is instruction. Instruction can be said as a piece of code to instruct the processor. Like suppose you are the elder one in your family and you need a glass of water. You instruct your younger sibling that please give me a glass of water. This line is called instruction. So by using these words, you make your sibling understand that you want a glass of water. Instruction is also same for computer. So when we need to tell the processor that what to do, or while performing a specific task, we need to instruct this. This is a type of this is what called instruction. Like add accumulator. By writing this piece of code, we instruct the processor to add accumulator. Second term, operand. What is operand? The number on which the operations will get performed is called operand. Suppose MBI A, 25. 25 is the number on which the operation is going to be performed. So 25 is our operand. Okay. The next term is a widely used term, and I think you guys didn't know processor still. So this specific description is for you guys who doesn't know what is register or doesn't have any kind of idea about what is processor and how the memory within the processor works. This is for you. And if you don't know about processor, don't worry, I think I can make you understand. But before that, I think you all know a little bit about C programming, right? So I think you all remember that suppose we need to declare a variable, we should suppose I have taken a C variable of integer type. But what are variables actually? Variable is a memory location. When we create a variable, it means that in the memory we have a specific location, suppose 1, 2, 3, 4. This 1, 2, 3, 4 is represented by C. But what happens in C programming is that we can't see variables. They are not visible. They don't have a physical existence. But when it comes to processor, then a temporary storage area that is built into a CPU have some physical existence is called registers. Say for example, if I'm okay, now we all know that from register 4040 to now like I9 and all, registers are used to store values. Okay, so as the processors change, maybe the names of the registers are changed, but not their usefulness. Okay, I think this question of addressing modes, if you are in second year of engineering and all, then this comes as a theoretical question and discuss about addressing modes. Now 8085 or 8086, all of them have quite similar addressing modes. Maybe when the processor is a little bit updated, then there are added quite more few addressing modes. So as 8086 processor is widely used all over in, like, if you are studying any computer science branch and all, so I will discuss about my addressing modes of 8086. Doesn't matter if you are learning about 8085, all of them are quite same, only 4 of them are newly added in 8086. But if you know about registers of 8086 processor, you can write this answer, and I think if it's a 10 mark question, you will get 8 or 9 out of 10. So let us start. Registers of 8086 processor. Suppose this is the processor. Within the processor there are registers, and this is the memory. You know that in memory we have programs also, and also the data related to those programs. So for example, if WhatsApp, it is an application is obviously a piece of code. So in memory that program is also stored, and if I ask you that what are the data of WhatsApp, suppose those pics, video, audio, all of them are data, they are also get stored in the memory. So what registers have to do, or suppose like we have to fetch some what a processor basically does is fetch, decode and execute. Remember I have told you in the first lecture. So what register is to do, they fetch the data, store the data, and while the processor needs the data, they send it. In 8086 there are 8 GPR. What is GPR? General purpose register. So we're gonna use only 4 of them on because only they are used while programming. It's not that the other ones are not used, but if you guys know only these 4, you can perform all the programs and all. So the 4 registers are A, B, C, D. Now they are of 16-bit register. These register can work as like separately, A lower, A higher, 8 bits, according to them B, C, D also, and they can also work as a pair. X stands for pair, they are from 16 bits. Okay, so lower byte 8 bits, higher byte 8 bits, X is a pair of 16 bits. Say for example 12H. Okay, now I think you guys are assuming that what is H. H stands for hexadecimal. If I can make videos on 8085 microprocessor, then I will discuss that why this hexadecimal number is used. But then, like till then, you should just understand that these are hexadecimal numbers used within the processor. I mean while programming on the processor. So hexadecimal number, suppose 1 2. 1 2 can be represented in binary in these forms. So 4B, 4-bit, 8-bit. So if we use a 8-bit processor, suppose AL, BL, etc., we can store 8-bit numbers, as well as if you use any 16-bit processor, then we can store them in AX, BX, this and all. So what is register? Say again. Registers are temporary storage built within the CPU to store data which have some physical existence. In C programming, we need to create variables so that we can operate on them. In microprocessor, the registers are already built, so we need not to make any external registers and all. They are already built within the CPU. We just need to operate on them. Okay, so these are the basic requirements we need to know to start the video. Now we can landing into the main topic about how many addressing modes are there, and let me discuss about them. Types of addressing modes. First, immediate addressing mode. As the name suggests, immediate. What does it mean? Instantly. When data is given in the instruction, then it is called immediate addressing mode. Okay, if you're learning 8085, then you can see whether there is I understand that it is an immediate addressing mode. Suppose I have written MBI A,25, it means that this 25 data should be stored in accumulator. Okay, now as I'm discussing about 8086, so the next example is more accurate. Move, like both of them are correct, but as I'm studying about, as I'm discussing about 8086, so I want you to focus on this. Move BL comma 30H. What does this mean? That BL register should get 30H value. Like in C programming, you used to create a variable, suppose A. Then we initialize this with suppose 45. Then what we can see that 45 gets stored in A. Same in this immediate addressing mode. When data is given in the instruction, then it is called immediate addressing mode. Okay. Next, register addressing mode. When data is given by the registers in the instruction, they are called register addressing mode. Suppose move BL comma CL. So in CL we have some data about 33. This instruction says the processor to move the data 33 in BL. Sorry. Okay. So this is register addressing mode. The third one is direct addressing mode. In this addressing mode, the address is given in the instruction. Suppose move BL comma 2000H. Okay, listen. From now till the end of your life, you should always remember, if there is a third bracket, you should understand that the value within this is a address, not data. And if you want to cross check this, see, BL is a 8-bit register, 2000H is a 16-bit number. You can't store 16-bit in a 8-bit register. So obviously this is not data. Then what is it? Okay, there is a third bracket. It means that it is a address. Okay, let me write this. Let me draw this for you. This is the memory. In the memory, this is the program gets stored. Move BL comma 2008. Okay. So first the MUP understand the program. This says that move BL comma 2008. What does this mean? First, go to the address 2008. See what the data is there. 33. Okay. Collect this data 33 and then put this in BL. Okay. Another example. Move DX comma. Okay, no. First, always remember only one byte, which means 8 bits, can be stored in one address. So 2000 can store a 8-bit number, 2001 can store another 8-bit number. This is how it follows. Now, if I have written move AH comma 3000H with a third bracket, this means first 3000H is an address. When it comes to, suppose there is 3000H, there are values stored 65. What the processor will do? It will collect the value 65 and then it will store it in AH. Okay. So direct addressing mode is when address is given in the instruction, and with the help of the address we can store the data in that desired register. Okay. Let's move on. Now I think you all are assuming that if we can immediately have the data in the instruction, why are we learning this kind of register addressing mode, direct addressing mode? Why do we need to learn them? Okay, all these addressing modes are equally important and you don't know that whether you have to use what kind of addressing modes. So this is why we should learn all the addressing modes very carefully, because maybe in the question there are some points when the data is given, so you can use immediate addressing mode. But what if the address is given? Then you have to perform something else. So let us have an exercise. Suppose the question is, take the data from location 4000, take the data from location 3000, add those two values, store the data in BL register, after that add 45H into the BL register and store the result at location 5000H. Okay, don't get nervous, do it yourself. First, take the data from location 4000, what I have taught you. So location 4000, so it is direct addressing mode. So this is location 3000H. From location 3000H, I get the data in BL register. After that, I get the data from 4000H in CL register. What are them? Direct addressing mode. Then add the two. And then add those two values. So in BL there is suppose 10 and in CL there is suppose 5. So I have to add them. Now add BL comma CL. This is register addressing mode. Then after that add 45 to BL register. So add BL comma 45. What does this mean? 45. Now after this, now BL is suppose 15. When I have written add BL comma 45, this means another 45 values also get added in BL register. Then store the result at 5000H. So move 5000H comma BL. You know, if you know C programming, that this is your source and this is your destination, right? Now okay, wait, add BL comma 45. This is immediate addressing mode. Why? Because data is given in the instruction. Then it is addressing mode. See, in this, like adding two numbers, we need so many kind of addressing modes. So you can't say that only immediate addressing mode can help you in programming and all. You have to know all of them to perform any particular task. Okay, move on. Here comes the most important addressing mode, the indirect addressing mode. If you know only those three addressing modes, they will help you to get 5% of programming, but the rest of 95% is done by this addressing mode, the indirect addressing mode. What is indirect addressing mode? When address is given by the register. See, there are only handful of registers, only A, B, C, D that we can use. So we need something else to perform the programs. We can use the memory to store huge amount of data. So we can't always rely on the registers for this. We have to use the memory. So then indirect addressing mode helps a lot. But before that, focus on this line. Address is given by the register. So the first type of indirect addressing mode is register indirect. Direct but in front of this. So first make this understand with the example is move CL comma third bracket BX. Okay, third bracket means this is an address. So first we need to go to BX. Now BX is a pair of BL and BH. Now in BL there is 12 and in BH there is 00. So we have to go to the memory location. Suppose this is the memory. I know that I'm not a good painter. Please make this clear, guys. Please understand. In memory there is a location 1200. Suppose there is a data gets stored 56. What we have to do? The data stored in the location pointed by BX. Now I think you remember pointer. So what this instruction is doing? BX is pointing at a particular address, that is 1200. In 1200 the data is stored, that is stored is 56. What this instruction suggests, instruct, you have to take this data 56 and stored in CL. Okay, so this is register indirect. The next one is base indexed. In this, the address equal to base register plus index register. So we know, suppose you know about array, right? Let me give an example. Int A of 5. So A is an array of size 5. Indexing them 0, 1, 2, 3, 4. This is an array. We know that the first this is known as base index. And if you are a programmer and if you are a good programmer, you know if we have this base index, we can collect any value from any memory location. Suppose if you know a of I, okay, I equals to 0, I can be 5. So if you only know the base index, after incrementing the base index, we can get another value. We only have to know the base address. So if there comes a programming where you're only given the base index as 5000, and this says that okay, give me the data from 5050 or give me the data from 5090, 5060, you obviously don't want to lose the base address 5000, right? We need to store 5000 at a particular register. So the base address is stored at BX and SI 50. SI is actually source index. This is a special type of register. No, this is a general purpose register in 8086. So we can store it in another register. Now, what we can do, that move CL comma BX plus SI. BX is initialized with 5000, SI is initialized with 50. Now what we can do, the data from 5050, suppose it is 33, it can get stored in CL. Now if we want to store the data from 590, only we have to increment SI. But with the help of this base index, we will never lose the base address of the memory that we always need. Okay, this is why base indexed addressing mode is used. The last indirect addressing mode is base relative plus indexed. You know from the last three ones, you know what is relative, what is indexed, and what is base. In this, the address equals to base register plus index register plus displacement. Suppose we have some kind sort of programming where we have the base register and the indexed, and suppose there is 5000, there is 5050, there is 5053. You have 5000, you have your SI as 50, you have your BX as 5000, SI as 50. But so what you can do, either you can increment SI or you can use a displacement of 03. Okay, so to make the programming more handful, to make it more useful, to make it more flexible, the more type of addressing modes are there. So move CL comma BX plus SI plus 03. What it suggests, that get the data from suppose 5053. This is why base relative plus indexed is used. Now the indirect addressing mode, you can either write, let's just write the address given by an register is called indirect addressing mode. You can write it also. In 8085, the base relative plus index or the base index or this relative index, not any kind of addressing mode is there in 8085. These are 8086 addressing modes. But if you want the examiner to make you know that I know these kind of instructions, it will be more impressive for him to give you marks. If this is a 10-mark theoretical question, you have to give more information. Okay, the last addressing mode, and this one is kind of my favorite. This is called implied addressing mode. What does implied suggest for? Hidden, right? When the operand is hidden, suppose we want to say something but we can't say it directly, we use implied addressing mode. Say for example STC. STC is set the clariflag flag. Here not any operand is presented, but with the help of this instruction, the microprocessor will set the clariflag flag to 1. This type of addressing modes are only applied to a particular register. Suppose STC is only applied on carry flag, CLC clear the clarify flag. This is also applied in CF. So we need not to specify that this should be applied in carry flag. The microprocessor is already instructed to apply this only on carry flag. So implied addressing mode is when the operand is hidden. Let's have a quick review. Immediate addressing mode, when data is given in instruction. Register addressing mode, when the registers are in the instruction. Then direct addressing mode. In direct addressing mode, the address is presented in the instruction. And then come indirect addressing mode, when address is given by register. And lastly, implied addressing mode, where operand is hidden. This is a full lecture on your addressing modes. Mark these lines of mine. First of all, if you write this full answer with example and those particular lines which are underlined and all, this is so important, then we can score good marks on exam. Before I end this video, I want you to perform a little bit exercise on the thoughts on the concept that I have taught you today. Suppose I think all of you have must thinking in your head that why are we using such a complex indirect addressing mode when we can use direct addressing mode? Okay, so suppose take the data from 5000 and stored in CL register. If we use direct addressing mode, then we can write move CL comma 5000H, right? But if we need to do this with indirect addressing mode, then we have to first initialized BX with 5000, then move CL comma BX, right? We have to do this. So why are we using this? If you are a programmer, your life doesn't end at adding two numbers. When you have to perform some application on series of numbers, suppose 5000 to 5010, okay, then what are you gonna do? You will add this number, move CL comma 5001. Obviously not, we can't do this. This is not an intelligent way to do this. We can perform this by using a loop. So when we want to add some series of numbers, or while we have to use series of some numbers, then indirect addressing mode gives you that flexibility. Only what you have to do, initialize this once and then suppose increment BX and run this in a loop. Your task is being performed. So to make your programming more useful, and when you have to small amount of time and small amount of memory, then this type of programming is used. Now I forget to discuss a particular type of addressing mode, that is register relative addressing mode. I'm really sorry that I have to discuss this now, but please listen to this carefully. Register relative, when the address equals to register plus displacement, suppose BX is the register and 03 is the displacement, then register relative addressing mode is used. Suppose we have given 2000H in BX and we need to know the data from 2005, then this type of addressing modes come to scene. Suppose we have move CL plus BX plus 03. So what does this mean? That BX plus 03 data will be get stored in CL, that is the data from this memory address. Like another example, move BX comma 2000H. First 2000H is stored in BX, then it will go to the memory. Now I have written move DL comma BX plus 05. What does this mean? 2000 plus 05, the data from here, it will get stored in DL register. Now if we need to, suppose what this helps is we have the base index always. Now if we just change 09, if we change the displacement, we will get the another data from the another memory location. Okay, so this is indirect addressing mode. I'm really sorry that I have to discuss this later. I hope this video helps you a lot, and thank you.